Welcome students. In this class we will be starting off with a new topic called as differential equations. Now foremost, what is a differential equation? This is a very important question. What is a differential equation? So what's your answer for that? Now the answer is differential equation is an equation which involves differential coefficients or differentials. So having given this definition, we will see some examples. So I'm going to be listing out a few examples. The first example would be e to the power of y times dy positive e raised to the power of, say, 2 times x dx is equal to 0. Example number 2 would be d cubed x divided by, say, dt cubed positive sum n cubed x is equal to 0. So the variable here is t and the differential is d cubed x over dt cubed. Example number 3 is, say, 2 times y is equal to x squared times dy over dx positive 3 times x divided by dy over dx. Example number 4, I can have this to be as dy over dx raised to the power of, say, some 4. The entire thing is raised to the power of 5 over 2, and probably this is equal to e raised to the power of some 2x. And finally, one more differential I can give. Dou squared y over dou x squared is equal to e raised to the power of, say, some 3x dou squared y over dou t squared. So these are all some of the examples. Now example 1, 2, 3, 4, they are all called as ordinary differential equations. So let me write that down, ODE. And example 5 is called as partial differential equation. Now foremost, we will have to now understand the order of a differential equation. What exactly is the order of a differential equation? So that is very much important. So let me state the definition here. The order of a differential equation is the order of the highest derivative appearing. Now when we call about the degree of a differential equation, this would mean it is the degree of the highest derivative. Okay, so order and degree. In case of degree, it is the degree of the highest derivative occurring in a differential equation. Okay, and you will have to understand that whenever we are trying to find the order and the degree, we will have to expand them in polynomial form or represent them in polynomial form. And after representing them in polynomial form, it is then that we will have to, or we will be in a position to find out the order and the degree. Students, we are being given the question. We are expected to form the differential equation for the family of circle represented as x squared positive, y squared negative 2 times ay is equal to 0, where a is an arbitrary constant. Now please observe that we just have one arbitrary constant, so we will have to just differentiate once. That's the idea. If you have two arbitrary constants, you will have to differentiate twice. If you have three arbitrary constants, you will have to differentiate the entire system 3 times. So what I would do is, I will start off by saying consider x squared positive, y squared negative 2 times ay is equal to 0. Next, what I will do is I will differentiate the entire system. So I will say differentiating with respect to x we get. Now dy over dx, you can write dy over dx as y dash. Have that in mind. So differential of x squared is going to be 2x positive, differential of y squared is going to be 2 times y times differentiation of y, that's dy over dx. I'm going to write dy over dx as y dash. Negative 2a is a constant, differentiating y, it will give me y dash. So we take 2 out and we rewrite the entire system as x positive y dash is equal to 2 times a y dash. So the 2's can be cancelled, and then I would write a to be equal to x positive y dash divided by y dash. So this is what I've got for a. Now if I were to take this system as 1, what I wish to do is I would like to take the value of a and substitute it in 1. So I will say that substituting a in 1 we get. So this is equal to x squared positive y squared negative, in fact I wish to move this 2ay to the other side, so I would have a 2y in place of a. I would be substituting x positive y into y dash divided by y dash. So I cross multiply. If I cross multiply, I get x squared positive y squared times y dash is equal to 2 times xy positive 2 times y squared y dash. Now what I wish to do is I wish to move this 2y squared y dash to this side. So I can rewrite this as x squared negative y squared times y dash is equal to 2 times xy. So this is the differential equation. In fact, I can rewrite this as x squared negative y squared times dy over dx is equal to 2 times xy. So this will be the solution for my question. Students, we will start off this class by performing problems on variables separable. Now it is important for us to understand the concept of variable separable by means of a definition. So this is the definition we will have to understand. So if in an equation, if it is possible to collect all functions of x and dx on one side and all functions of y and dy on the other side, then we say the variables are separable. And the general form of such equation is some function. Then you to get the output, you will have to integrate the left side and the right side, and you will receive an arbitrary constant, and this will be the solution. This is the solution. So to start off with, we will do a question. Probably after understanding the question, we'll be in a position to proceed further with other questions. So we are asked to solve this. Solve dy over dx is equal to x times 2 times log x positive 1 divided by sin y positive y times cos y. So our objective is to take all the x on one side and the y on the other side. So probably what I will do is I will have, it's up to you, you can have y on the left and x on the right. So since I've got sin y positive y times cos y over here featured as a denominator, probably I will have y on the left side. So this is going to be sin y positive y times cos y times dy is equal to x times 2 times log x positive 1 times dx. So this is what we've got. So now what we have to do is we can clearly integrate this. So I'm going to rewrite this as 2 times x times log x positive x, and you got that dx there. On the left side I can write this as sin y. Now let me just have one more step. Sin y plus y times cos y times dy. Now if I were to remove the parenthesis, this is going to be sin y times dy positive y times cos y times dy is equal to 2 times x times log x times dx positive x times dx. So I will be performing the integration like this. Now this can be rewritten as 2 times integral x times log x dx positive integral x times dx. Over here it's integral sin y dy positive integral y times cos y dy. So this is what I've got. Now I will use this space over here. First I will integrate that. It's x times log x dx. So we will use Liate concept, L-I-A-T-E. So if I were to use Liate, I get u is equal to log x. So du is equal to 1 over x. So it's going to be dx over x, and my dv is x times dx. So if I were to get the v, this is going to be x squared over 2. So uv negative integral v du, that's going to give me log x, and my v is x squared over 2. So I'm going to place it over here, minus my v is x squared over 2 times du is dx over x. I can cancel a x out. So if I were to cancel a x out, so this is going to give me x squared over 2 times log x, and this is going to be 1 over 2. If I were to integrate, this is going to give me x squared over 2. So I can rewrite this as x squared times log x negative x to the power of 2 divided by 4. So that's okay. I can take that and substitute it into the equation, or I should say in the integral present here. So this is going to be 2 times, we have integrated this, so this is going to be x squared over 2 times log x negative x squared over 4. Integration of this is going to be x squared over 2. So if I were to bring the 2 inside, so this is going to be 2 and 2 can be cancelled, so I get x squared times log x. So that's one particular term, and then this is going to give me x squared over 2, right, and followed by x squared over 2. So this is what I've got. Now clearly you can see that negative x squared and positive x squared can be cancelled, giving me x squared times log x. This is for one term on the right hand side. So now I need to obtain the value for this. Now you can clearly see that this is integral y times cos y dy. So let me perform that over here. So using the Liet, what I would do is you got logarithmic inverse algebraic, right? So this is algebraic, so I'm going to take u is equal to y, and du is equal to dy, and dv is cos y dy, and my v will give me, when I integrate this is going to give me sin y, right? So uv minus integral v du, that's the formula. My u is y, my v is sin y, and followed by my v is sin y, my du is dy. I integrate sin y, I get negative, 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 that will be a cos y, and this is going to give me y times sin y. So all I need to do is substitute this over here. So integrating sin y, this is going to give me negative cos y, followed by my quantity y times sin y plus cos y. You see that negative cos y, positive cos y gets cancelled, giving me y times sin y. So this is going to be y times sin y. We need to have an arbitrary constant, so I place the arbitrary constant. So this is the outcome that we have got. So probably you can rewrite this as, say, x squared times log x negative y times sin y is equal to c. This is also possible, you can also write it like this, because this is an arbitrary constant c, right? I know what you are thinking, why have I not placed it as negative c? It doesn't matter. So this is just a constant, so you can also represent the solution like this or like this. So based on your requirement, what is expected. Now let us move on to do another question. We are asked to solve this. Solve, say, dy over dx is e raised to the power of, so 3x negative 2y positive x squared e raised to the power of negative 2y. So this is what we've got. So as usual, we will have to get rid of, in other words, place y in one side and x in the other side. I can rewrite this as e raised to the power of 3x times e raised to the power of negative 2y positive x squared times e raised to the power of negative 2y. I can take e raised to the power of negative 2y out. This will give me e raised to the power of 3x positive x squared. So this is what I've got. Now this is completely x, this is y. What I can do is I can push this guy down. So this is actually dy over dx, right? dy over dx. So if I were to push it down, this is dy divided by e raised to the power of negative 2y is equal to e raised to the power of 3x positive x squared times dx. So this is what I've got. Now I can push it to the, I can push this guy to the numerator. So this is going to be e raised to the power of 2y times dy is equal to e raised to the power of 3x positive x squared times dx. So if I were to integrate both sides, this is going to be e raised to the power of 2y divided by 2 is equal to e raised to the power of 3x divided by 3 positive x to the power of 3 divided by 3 positive c. So this is what we have got. Now of course you can rewrite this based on your requirements, and what I would do is I would actually multiply both, or throughout I would multiply by 6. If I were to multiply by 6, let me write that down. So this is going to be 6 times e raised to the power of 2y divided by 2. So that's going to be 6. 2 divides 6 3 times, right? So let me just write that 3 down. So 3 raised to the power of e raised to the power of y is equal to, this is going to be 2 and 2, so I will just place 2 e raised to the power of 3x positive x cubed. Now there is a 6c, right? Because I'm multiplying the entire component, entire equation by 6, so this is going to be 6c. So you can also have it like this, or you can replace the 6c with a capital C. So it still means the same because this c is arbitrary constant. Students, we are given this question, dy over dx is equal to sine of x positive y, positive cos of x positive y. Now it's challenging to separate x from y because they are clubbed with the operator addition, but there is a technique. Now what we got to do in situations like this, you will have to make a substitution. So you got to say let x positive y be equal to t. Now when you differentiate this is going to be 1 positive dy over dx is equal to dt over dx. So from here I can write dy over dx to be equal to dt over dx negative 1. So this will be the substitution. So if I were to take this as 1, so what I'm going to do is, therefore I can write 1 to be as, in place of dy over dx, I need to substitute dt over dx negative 1 is equal to, in place of x positive y it's sine t, x positive y is going to be cos t. So we've got a nice bit of equation which is actually separated. So what I'm going to do is I'm going to take 1 on that side. So this is going to be dt over dx is equal to 1 positive sine t positive cos t. So this is what I've got. Now if I were to take the dx onto the right and bring this down, this is going to give me dt over 1 positive sine t positive cos t is equal to dx. So this is what I've got. Now you can either write it like this also, dx is equal to dt divided by 1 positive cos t positive sine t. It still means the same. Now I would be integrating both sides, right? Now for integration to happen, I'm going to make this slight alteration. So that is, let my t be equal to say some 2 theta. So from here dt is equal to 2 times d theta. So this is equal to, in place of dt it's d theta with a 2 there. This is going to be 1 plus cos t. T is 2 theta, so it's going to be cos of 2 theta positive sine t. Sine t is sine of 2 theta. Now why did I place cos t? Because you would be in a position to see that there is a formula there. What is the formula? The formula is 1 plus cos 2 theta divided by 2 is equal to cos squared theta. So I exactly wanted you to see that. So if I were to substitute, replace 1 plus cos 2 theta divided by 2 as 1 plus cos 2 theta to be equal to 2 times cos squared theta, then this is going to be 2 times d theta divided by, so this is 2 times cos squared theta positive. Now sine 2 theta is 2 times sine theta cos theta. Okay, so this is 2 times sine theta and cos theta. You can write it like that. You can just take cos squared out. Now clearly you can see that you got a 2 here, you have a 2 here, you have a 2 here. So all these 3 2's can be cancelled. So I can now take cos squared out, cos squared theta out. That will give me 1 positive sine theta divided by cos theta, right? Cos squared theta multiplied with sine theta over cos theta will produce me this sine theta cos theta. Now we know that sine theta over cos theta is tan theta, and 1 over cos squared theta is secant squared theta. So this is going to be equal to integral secant squared theta d theta divided by 1 positive tan theta. Now what I wish to do, I would like to use this space here. Okay, so I'm going to say let 1 positive tan theta be equal to some p. So differential of tan theta is going to be secant squared theta d theta is equal to dp. So if I were to substitute, this is equal to, in place of secant squared theta d theta, this is going to be my dp. In place of 1 plus tan theta, this is going to be my p. If I were to integrate this is going to be my log p, which is nothing but my log of 1 positive tan theta. So this is what I have got. Now you will have to understand that theta, since t is equal to 2 theta, so therefore theta is equal to t over 2. So this is equal to log of 1 positive tan of t over 2. This is what I've got. But t is equal to x positive y, right? So you take that x positive y and you substitute it here. So let me use the space here. So this is going to be equal to log of 1 positive tan, my t is x positive y, divided by 2. So this is what I've got. Now this looks nice, but on the left side we will have to take note of this. When you integrate, you are actually getting x here, and x here. That x is coming here, okay, because integral of dx is going to be x. So on the left hand side I get an x, and to complete the equation I need to add an arbitrary constant. Probably if you're not happy with x positive y over 2, you can rewrite this as log of 1 positive tan of 1 over 2 times x positive y. You can write it like this, plus arbitrary constant c. So that on the left hand side, make sure to place the x. So this is the solution for the question. Students, we are given this question: solve dy over dx is equal to 4 times x positive y positive 1 raised to the power of 2, given that at x is equal to 0, y of 0 is equal to 1. Now what I wish to do is, I would like to take this substitution. Let 4 times x positive y positive 1 be equal to some t. This would mean I get 4 positive dy over dx is equal to dt over dx. So from here I will have dy over dx is equal to dt over dx negative 4. So now what I can do is I can substitute this in place of this. So let me take that as 1. I take that as 1. Then I can say, therefore I can rewrite 1 as, in place of dy over dx, this is dt over dx negative 4. In place of 4x positive y positive 1, I substitute t squared. So I push this 4 to the other side. So I get dt over dx is equal to t squared positive 4. I move this t squared positive 4 down. So this is dt over t squared positive 4 is equal to dx. Now integrating both sides, this is going to be integral dt. I'm going to rewrite this as 2 squared positive t squared is equal to, I'm not going to integrate it now on the right side. So this is equal to integral dx. Now by formula this is going to be, now this is nothing but 1 over a tan inverse of x over a. So t over 2, integration of this is going to give me x positive c. Now I would take this 2 to the right side, so that would mean I can rewrite it as tan inverse of t over 2 is equal to 2 times of x positive c. But in fact I can push this tan inverse to the other side. So there's going to be t over 2 is equal to tan of 2. In fact I can rewrite it like this, 2x positive 2 times c, right? I take the 2 inside. But my t is actually 4x positive y positive 1, right? So I substitute here. So what do I get? I get 4 times x positive y positive 1 divided by 2 is equal to tan of 2x positive 2 times c. Now I can move this 2 to this side, so that would give me 4x positive y positive 1 is equal to 2 times of tan of 2x positive 2c. So fair enough. Now we are given, what are we given? when x is equal to 0, y of 0 is equal to 1. This is the value that is given, right? So that would mean x is equal to 0, this vanishes, and y value is 1. 1 is equal to 2 times, I have a tan of x is equal to 0 plus 2 times of c. This is what I've got. So I can rewrite this as 2 is equal to 2 times of tan of 2c. 2 divides 2 once, so it's going to be 1 is equal to tan of 2c. I can move this tan to the other side, so this is going to be tan inverse of 1 is equal to 2 times c. But what is tan inverse of 1? That's pi over 4 is equal to 2c. So this means I got c is equal to pi over 8. So I've got the value for c, right? Pi over 8 is a value. Now I wish to substitute it in this, say I'm going to take this as 2. So therefore 2 can be rewritten as 4 times x plus y plus 1 is equal to 2 times tan of 2x plus 2 times, my c is pi over 8. I substitute that. So this is going to be 4 times x plus y plus 1 is equal to 2 times tan of 2x positive pi over 4. So this is the final answer for the question, students. So we will move on to the next one. Students, we have a question. It's given that there is a function defined from R to R, and that with f of 0 is equal to 0, and it is stating that y is equal to f of x satisfies this differential equation. Now, having given this information, they want us to find what happens to the function as x is tending towards negative infinity. So foremost, what I wish to do is I would like to start by saying consider dy over dx to be equal to, now 2 positive 5y times 5y negative 2. Now what I wish to do is I would like to rewrite this as 5y positive 2 times 5y negative 2 is equal to dy over dx. Now move all the y to one side and the x to the other side. So the most comfortable way to do that is keep the y on the left and bring 5y positive 2 times 5y negative 2, and on the right hand side I got dx. Now we can integrate this, but to make integration possible we will have to use partial fractions. But it is imperative to understand that not always that you need to apply partial fractions. Some of the times you can use straightforward techniques. For example, on the left hand side I can rewrite this as 5y positive 2 negative of 5y negative 2 divided by 5y positive 2 times 5y negative 2 is equal to integral dx, and this has to be integrated with reference to dy. Now clearly you can, there's a parenthesis there. Clearly if you can see that 5y negative 5y, they get cancelled. 2 negative of negative 2 will give me 4. I need to get a 1 there, so I'm going to multiply by 1 over 4. Now clearly you can see that this is easily solvable, and for the simple fact that whenever I use the concept of algebraic law, say writing a positive b divided by c as a over c positive b over c, then I can easily integrate those terms. So that is the basic idea for this. So if I were to rewrite this, this is going to be 1 over 4 integral, the numerator is 5y positive 2 divided by the denominator 5y positive 2 times 5y negative 2 times dy. Of course maybe I can place a huge parenthesis there, followed by integral 5y negative 2 times dy divided by 5y positive 2 times 5y negative 2. Now clearly you can see that 5y negative 2, 5y negative 2, 5y positive 2, 5y positive 2, they can be cancelled. Of course, let me place the parenthesis. This is integral dx. Now this is going to be integral dy divided by 5y negative 2 followed by integral dy divided by 5y positive 2. This is equal to x. Now what is this? This is going to be integral dy over 5y negative 2. This is going to be my log, right? Log. Now let me show you what happens if you have a quantity like this. Now you got a quantity like this, say integral dx divided by, say, some 7x minus 2. You will say let 7x minus 2 be equal to some t. This is going to be 7 times dx is equal to dt. So if you have to substitute in place of dx, you have to substitute dt over 7 divided by t. So this is going to be ln of t. My t is going to be 7x negative 2. Of course there is a coefficient, so that has to be multiplied. Of course we need to place the arbitrary constant. So all these things, they follow, right? I'm just going to apply the same principle what you see here over here. So this is going to be 1 over 5 times ln. I need to use the modulus. I wanted to have a defined function, so that's the reason. So it's going to be 5y negative 2 followed by negative 1 over 5 times ln 5y positive 2, which is equal to x. Now we know a law. What is a law? We know that ln of a negative ln of b is equal to ln of a over b. So by this, what I can do is I can rewrite this as 1 over 4 times. This is actually 1 over 5, right? I can take 1 over 5 out and rewrite this as ln of 5y negative 2 divided by 5y positive 2 is equal to x. So this is what I have got now. Now clearly you can see that 4 times 5, 20, that can be multiplied. And let me place in one more step. So this is going to be 1 over 20 times ln of 5y negative 2 divided by 5y positive 2. This is equal to x. I can cross multiply. Now if I write a cross multiply, let me use this space here. So that would give me ln of 5y negative 2 divided by 5y positive 2 is equal to 20 times x. Now we know there is a property in logarithms. So what is that? You have something like this. Ln a to the base e is equal to some y. Then you can write a is equal to e power y, because this is base natural logarithm. So I can use that concept and rewrite this as 5y negative 2 divided by 5y positive 2 is equal to e raised to the power of 20x. Now the question wants us, the question says when x is, this is what we have got. Now the question wants us to find the functional value when x is tending to negative infinity. So that is the most important thing. Now if you were to substitute here e raised to the power of 20 times negative infinity, as x is tending to negative infinity, this quantity, this is e raised to the power of negative times infinity times 20. This will be tending towards 0. So we have got, what have we got? We got 5y negative 2 divided by 5y positive 2 is equal to 0. You cross multiply, you get 5y negative 2 is equal to 0. Move the 2 to the other end, you get 5y is equal to 2. So therefore y is equal to 2 over 5, which means y is equal to 0.4. So this is what is the requirement, and we have got that solution. Students, we are given this question: if 2 positive sin x of dy over dx positive y positive 1 of cos x is equal to 0 and that y of 0 is equal to 1, we are expected to find y of pi over 2. Now this is a competitive examination question, so let's do that. Now foremost what we need to do is, I'm going to say consider 2 positive sin x times dy over dx positive y positive 1 times cos x is equal to 0. So I will move this to the other side. So this is going to be 2 positive sin x times dy over dx is equal to negative of y positive 1 times cos x. Now what we can do is we can pull in the cos x and the y terms to, you know what I mean, keep the y terms on the left and cos x terms and the x terms on the right hand side. So I will have a cos x here. I'm going to push this term 2 positive sin x down, and then I will push up this dx. But we got a negative sign. Probably we can place the negative sign along with the x term. And on the left hand side, you only have dy. So this is what you got. Along with that, I would have to make sure that this y term comes down. So this is going to be y positive 1. Right? So this is the slight rearrangements we have got. Now we need to integrate. So integrating both sides. Of course, the left hand side is going to be ln of y positive 1. Not much of an issue. But for the right side, what I'm going to do is I'm going to say let me make the following substitution. Let 2 positive sin x be equal to t. This is cos x dx is equal to dt. So if I were to make the substitution, this is equal to, I have a negative sign, cos x dx is going to be dt. This is going to be t. Now when I integrate this is going to be negative ln of t. Now my t is 2 positive, so it's going to be negative ln of 2 positive sin x. So this is what I have got. Now we need to place the left hand side, which is ln of y positive 1, and that has to be accompanied with an arbitrary constant. So I can place an arbitrary constant, say some c. Now if I were to move this negative term to the left hand side, this is going to be ln of y positive 1 positive ln of 2 positive sin x is equal to c. Now there is a law which says that ln of a positive ln of b is going to be ln of ab. So using this formula, this can be rewritten as ln of y positive 1 times of 2 positive sin x. Right. Now this c, what I wish to do is, I've got a c here, I want to rewrite this as ln c, because you got logarithmic quantities on the left hand side. You can very well use logarithm to represent this c. Now removing log on both sides, you can, in fact if you want, you can just state that removing log on both sides. Don't cancel them, just use the word removing log from both sides. So when you do that, when you remove log from both sides, you would get y positive 1 times 2 positive sin x. This is what you get. And of course the log gets dropped and you can have the c there. Now the question says when x is equal to 0, the value of y is equal to 1. You can clearly see that. This is what the question says. Let me show that to you. Okay, so we are going to use that concept. So when x is equal to 0, y is equal to 1. So sin 0, this goes away. So you get 1 positive 1 times of 2 is equal to c. Therefore the value of c is 4. Now if I were to take this as, say, sum 2, therefore I can rewrite 2 now with the elimination of the constant. Therefore 2 can be rewritten with the elimination of the constant. Elimination of constant. I can do that. So that is going to be y positive 1 times 2 positive sine x is equal to 4. Now the question comes is, we are expected to find when x is equal to pi over 2, what is y? So let's do that. So this is going to be y positive 1 times of 2 positive sine pi over 2 is equal to 4. Sine pi over 2 is 1, so 2 positive 1 will give me 3 times of y positive 1 is equal to 4. I can push this down, so I get y positive 1 is 4 over 3. I can move the 1 to the other side. I get y is equal to 4 over 3 negative 1, which means y is 1 over 3. So this is the solution to the question. Students, we have been given this question: y over x times dy over dx, positive x squared positive y squared negative 1 divided by 2 times of x squared positive y squared followed by a positive 1, and that is equated to 0. What we would do foremost is to make the following substitution. So I'm going to say let x squared positive y squared be equal to t. Now when I take this, I will be differentiating both sides. Differentiating with respect to x, we get, this is going to be 2 times x, this is going to be 2 times y times dy over dx, this is going to be dt over dx. Now what I would do is I would just retain dt over dx on one side, and I will try to move the quantities of x the other side. So this is going to be 2 times y dy over dx is equal to dt over dx. I am going to move this 2x to the right, and that's going to be negative 2 times x. Now I will divide throughout by 2x. So that would give me, this is going to be 2y over 2x dy over dx is equal to 1 over 2x dt over dx negative 2x over 2x. Now clearly the 2 that you see can be cancelled, the 2x can be cancelled, and that would in turn give us y over x dy over dx is equal to 1 over 2x times dt over dx negative 1. So what we will have to do is we will have to make use of this substitution for our question. So if I were to take this as 1, I can clearly say that therefore 1 can now be rewritten as, in place of y over x times dy over dx, I'm going to replace it with this. So that's going to be 1 over 2x dt over dx negative 1 positive, now x squared positive y squared. Now we have taken the substitution that x squared positive y squared is equal to t. So I'm going to place t there. So this is going to be t negative 1 divided by 2 times t positive 1 is equal to 0. Probably I will rewrite it again. So I will just keep this term on the left and I will move all other terms to the right. So that would mean I get 1 over 2x times dt over dx is equal to, this is going to be 1 followed by negative of t. So let me just place a parenthesis like this. So I don't need to place a parenthesis, but I have started. So this is going to be t negative 1 divided by t positive 1, and we will have to use the LCM and rewrite it. So if I were to use the LCM, now what I'm going to do is I'm going to use the LCM here. So 2t positive 1, so this is going to be 2t positive 1 negative t positive 1. 2t added with t would give me t, positive 1 added with positive 1 will give me 2. This is going to be 2t positive 1, right? So we got a quantity going, and on the left side I got 1 over 2x dt over dx. Now what I wish to do, I would like to make the separation here. So probably I can use this space here. So this one I'm going to rewrite it like having dt. I'm going to push this t positive 1 down, t positive 2 down, and I'm going to take 2t positive 1 up. So this is going to be 2t positive 1 up. This is going to be equal to, I'm going to take 2x up, and along with 2x I will have a dx also. So this is what I've got. Now rewriting, let me rewrite this. So that I get 2t positive 1 divided by t positive 2 times dt is equal to 2 times x dx. I can rewrite this as 2t over t positive 2 positive 1 over t positive 2 times dt. This is equal to 2 times x dx. Now clearly you can see the degree of the numerator is same as the degree of the denominator, right? So in that case we will have to defragment it. Now you can use many different ways to defragment this, but what I would do is I would like to defragment this in this following fashion. So I would like to rewrite this entire thing as t positive 2. Now this has got a 2 there, so let me place a 2 over here. So 2 times of this would give me 2t along with the 4. So I need to have a positive 1 here, because if you were to see this quantity, it's 2t positive 1. But I would get, if I were to use this component, I would get a positive 4. So I need to get rid of the additional 3. So I will place a 3 like this, and then this has to be multiplied with dt, right? So this is equal to 2 times x dx. Now this is clearly the quantity that we have over here. So what I wish to do is I would like to integrate this now. So this is return as, let me rewrite this, 2 times dt negative 3 times of dt divided by t positive 2 is equal to 2 times integral x times dx. Now this is going to give me 2 times t followed by negative 3 times. This is going to give me ln of t positive 2, and this is going to give me 2 times of x squared divided by 2 positive c. Now I can cancel this, and then I will have to make some changes. So I need to get rid of this x squared, which I can, in fact I need to get rid of this t. So let me write that down. Since t is equal to x squared positive y squared, if I were to take this as 2, therefore 2 can be rewritten as 2 times of x squared positive y squared negative 3 times of ln. Now our t is x squared positive y squared, so substitute that x squared positive y squared followed by a positive 2, that's fine, and I have a x squared here on the right hand side, and that has to be placed with an arbitrary constant. Now what we can do is we can still simplify this. This is going to be 2 times x squared. I can bring this x squared here followed by 2 times y squared negative 3 times ln of x squared positive y squared positive 2 is equal to c. I can club these two together, and that would give me x squared positive 2 times y squared negative 3 times ln of x squared positive y squared positive 2 is equal to c. So this is a beautiful question, students. Now what I wish to do is I would like to give you all a few questions to try out. So try these questions. Okay, these will not only improve your power in differential equations, but it will prepare you for greater challenges. So question number 1, all of these things are solved. Okay, you got to solve this. So it's going to be y times square root of 1 negative x squared times dy positive x times root of 1 negative y squared times dx is equal to 0. That's question 1. My question 2 is going to be y over x dy over dx is equal to square root of 1. All these questions are based on whatever I have worked. So it's not something that I'm giving you all to try it afresh, but they're all which we have worked already. So dy over dx is equal to x times e raised to the power of y negative x squared if y is equal to 0 when x is equal to 0. So 1, 2, 3, just 3 questions you can solve, and probably you can, let me give you the 4th one. This is really a beautiful question. E raised to the power of x times tan y times dx positive 1 negative e raised to the power of x times secant squared y times dy is equal to 0. This is a lovely question. Probably I'll stop with number 5. This is dy over dx is equal to e raised to the power of 2x negative 3y positive 4 times x squared e raised to the power of negative 3y. So 5 questions, and you can put your solutions in the comment box. Thank you, students. Enjoy your night.